My topic is Pinpointer. It is a counter-sniper system developed by a team of researchers at Vanderbilt University. Existing counter-sniper systems use acoustic, visual, infrared, or electromagnetic signals related to gunfire. Pinpointer is a combination detection system, that is, it utilizes both shockwave detection as well as muzzle blast detection to accurately determine the location of the shooter and the trajectory of the bullet. Muzzle blast is the sound created by a rifle barrel after a shot, and shockwave is the pressure wave that is created by a supersonic bullet. The main limiting factor in the existing system is the requirement for line of sight, which is a major impediment in urban environment. In fact, the performance of most of the current acoustic systems significantly degrades when used in the concrete jungle, since some of the few available sensor readings are typically corrupted by multipath effects. The system is made up of many nodes depending on the deployment area. Instead of using a few expensive acoustic sensors, Pinpointer uses a low-cost ad hoc acoustic sensor network. The basic idea is simple. Using the arrival times of the acoustic events at different sensor locations, the shooter position can be accurately calculated using the speed of the sound and the location of the sensors. These nodes record various signals depending on each shot and send their data back to the base station through data aggregation and routing service, for example, to a laptop or PDA for calculations. The basic system architecture can be seen in the figure. The detection algorithm of Vanderbilt device is based on two main assumptions about a bullet. One, the muzzle blast expands spherically from the shooter's location, and two, the shockwave expands conically along the path of the bullet. After deployment, the sensors automatically establish an ad hoc communication network, perform self-localization, establish a common time base, and the system is ready to use. Sensor fusion is the algorithm used by fusing the data received from the individual mode. According to the Vanderbilt team, the system has a latency of less than 2 seconds and the 3D localization error of less than 2 meters. Sensors in the Pinpointer system are second-generation UC Berkeley Mica 2 modes connected to a multi-purpose acoustic sensor board running TinyOS. Each multi-purpose acoustic sensor board is designed with 3 acoustic channels and a Xilinx Spartan 2 FPGA. The custom acoustic sensor daughter card is developed where the necessary signal processing algorithms for signal detection and time stamping are executed on the onboard FPGA. The board also has low sensitivity microphones and pressure sensor for shock wave. The mode performs various services such as time synchronization, data aggregation, message routing, task scheduling, radio communication, I/O processing, and different application-specific routines. Pinpointer uses various wireless protocols for its operation. First one is radio interferometric positioning system that utilizes standard Mica 2 modes for self-localization. The radio interference created by two simultaneously transmitting nodes is used to determine the relative position of the modes. The flooding time synchronization protocol utilizes a single broadcasted message to obtain time synchronization reference points between the sender and its neighbor. Nodes broadcast time synchronization messages periodically and synchronize their clocks to that of an elected leader. The directed flood routing framework networks allow the rapid development of application-specific routing protocols based on directed flooding. The framework automatically supports data packet aggregation and allows in-network data packet filtering and alteration. The remote control utility enables the monitoring and control of individual or group of modes. Pinpointing techniques serve as a great business benefit as the sensor inside it finds its application in the construction firms such as road construction, earth moving, and fleet management. In road construction and earth moving, the system when installed on board the earth moving machine can tell whether the correct grade has been reached. Additionally, more precise application of pesticides, herbicides, and fertilizers is possible through pinpointing technology, thus reducing expenses and producing a higher yield. Talking about the future developments of the pinpointing sensor networks, automobiles can be made to move on their own without the assistance of a driver. The car itself will decide which roads to take and will arrive in the destination at a very efficient rate of travel. Another aspect of development is in the military to make their weapons have an extra edge over the enemy with the use of unmanned aircraft for tracking and spying on the enemy. Smart missiles are another concept of the future. These missiles will be able to choose and destroy the given target. They will automatically fire when the required specifications are met. They will be able to travel large distances and hit the target with pinpoint accuracy. Thank you.